Creating, altering, and dropping indexes. Here you can see some general syntax diagrams for creating, altering, and dropping indexes. Once again, a lot of it is grayed out because it's out of scope. Most of the grayed out of scope specification details are database administration, and we're not onto that yet. That will be in a subsequent course. Let's look at creating an index. We can create an index which is unique or a bitmap on a certain schema on a certain set of columns, where we say schema, table, or alias, column, 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 etc. or expression. We can compress the index, we can no sort and reverse. When we alter an index, we can rebuild it. Rebuilding an index really restructures the binary tree in a B-tree index. It can remove any skewed aspects of the entire tree. In other words, it can make it more efficient. It is a good idea to rebuild binary tree indexes periodically. If there is any update or insert or delete activity on bitmap indexes, they should be rebuilt often because they overflow very fast. They're very prone to performance problems when changing bitmaps. Be very careful using bitmap indexes. Once again, we can compress and reverse. The drop index statement is very simple. You just drop the index. Let's go and look at our concert schema again. We're interested in looking for index creation statements. We have a few of them in here. So let's open up the schema file. Here we have category, venue, number of constraints. Note, a primary key constraint will create an internal index. A foreign key constraint will not. A unique key constraint will also create an internal index. This is because uniqueness is required, so Oracle has to check every value. Therefore, it automatically creates a unique index for both primary and unique constraints. Enough of that for now. Here's a create index statement. So we say create index with the index name on the table show on the act ID. This is really an ascending index created on the act identifier. We've created another index on the venue and on the category. Now this is interesting because what we're doing is we're actually creating indexes on the foreign keys in the show table. In other words, the IDs that look at the category table, the venue table, and the act table. Now as you remember, I told you just now, foreign keys do not automatically create internal Oracle indexes. Primary keys and unique keys do. Primary key and unique key constraints do. Foreign keys don't. So you have to create indexes for those foreign keys. There can be locking issues when internal checks of referential integrity occur between the parent and child tables if the foreign keys do not have indexes created on them. Remember, a key is not the same thing as an index. A key is a primary key, or a foreign key, or a unique key. They are constraints, and they are applicable to referential integrity. An index is a separate file created. So remember to create indexes on your foreign keys. Here's all the indexes I have in my schema. Let's go and create a simple index. Let's take a look at the show table. Looking at the show table, let's create or attempt to create a unique index on the show date and venue ID columns in the show table. As you can see, it gives us an error. This is because there are duplicate values, even with the composite taken into account, which cannot be used to create a unique index. Let's take a look at those values. Right at the end, you see we've got 4 nulls, and we've also got duplicates. Therefore, the nulls and or the duplicate venue IDs will not allow me to create a unique index. All I wanted to show you was this unique index error. So now you know what cannot create unique index duplicate keys found means. Let's go and create an index that will work. So we create a non-unique index on the show date venue ID columns. There's my index. Now let's alter the index. we rebuilt the index. Rebuilding the index simply restructures the index and, if you like, unskews the binary tree. A binary tree should be balanced. The rebuild command will rebalance the tree by rebuilding the index completely. An unbalanced tree is a result of a lot of updating or a lot of inserts in one particular area. Let's drop the index since we don't need it anymore.